This question is from Engineering Mathematics for 2 marks. For the integral 0 to pi by 2, 8 plus 4 cos x dx, the absolute percentage error in numerical evaluation with trapezoidal rule using only the endpoints is. So this is a numerical answer type question and we need to round off the solution to one decimal place. The accepted answer range for this question is 5.1 to 5.5. We need to remember one point that whenever it is asked to calculate absolute percentage error for any particular integral, first we need to calculate the integral value using analytical method, and then we will start solving this using trapezoidal rule. Then it will be easier for us to calculate the absolute percentage error. Let's move on to the solution. Let us start the solution with analytical method. Let us consider that as 1 is equal to integral 0 to pi by 2, 8 plus 4 cos x dx. When you integrate that with respect to x, we get 1 is equal to 8x plus 4 sin x with lower limit as 0 and upper limit as pi by 2. When we substitute the upper limit and lower limits and simplify that, we get 1 is equal to 16.5663, which is the analytical value of the given definite integral. Now let's move on to the numerical method, which is trapezoidal rule. Let us first know what is trapezoidal rule. To calculate any definite integral according to the trapezoidal rule, integral a to b f of x dx is equal to h by 2 into y0 plus yn plus 2 into y1 plus y2 plus so on up to yn minus 1. When you look at the question clearly, we are asked to find out the numerical evaluation for this particular integral using trapezoidal rule only at the endpoints. That is, we need to calculate the numerical method for this particular integral only at 0 and pi by 2. That means that the number of intervals become 1. So, the trapezoidal rule changes as integral a to b f of x is equal to h by 2 into y0 plus yn. To calculate this particular integral, we need to know what is the value of h. H is nothing but step size, which is upper limit minus lower limit by number of intervals, and since in this particular question the number of intervals are 1, h becomes pi by 2, which is the upper limit, minus 0, which is the lower limit, so h becomes pi by 2. Now let us just calculate what is y0 and yn. Y0 is nothing but just substitute the lower limit for this particular question in the given integral, that is y0 is equal to 8 plus 4 cos 0, and simplifying that will give us y0 is equal to 12. Yn is nothing but just substitute the upper limit, that is pi by 2 in the given integral, that is 8 plus 4 cos pi by 2, which gives us 8. Now when we apply the trapezoidal rule, let us consider this numerical integral as 2 is equal to integral 0 to pi by 2, 8 plus 4 cos x is nothing but, according to the trapezoidal rule, only at endpoints we have h by 2 into y0 plus yn. Now we know the value of h, we know y0 and we know yn. Just substitute the corresponding values and simplify to get 2 is equal to 15.7079. So 15.7079 is the numerical solution of the given integral. So now in order to calculate the percentage error, we will always take analytical value minus numerical value by analytical value into 100. So when we substitute the corresponding values and simplifying that, will give us the percentage error as 5.2 approximately.